Hello everyone, I'm Teacher Tangs. In this video, I'm going to teach Chapter 6 Gradient and Area under a Graph, Speed times Graph. This type of graph is most popularly asked in SPM Paper 2 Part A. Alright, look at the concept of speed times graph. The gradient of a speed times graph represents the accelerations of the object. Positive gradient indicate the object is accelerating. Negative gradient indicate the object is decelerating, means speed is decreasing. Zero gradient indicate the object is moving at an uniform speed. This part normally will ask the durations object in uniform speed, t2 minus t1. Total distance traveled equal area under the graph. So normally we will use the trapezium formula to find the area under the graph. Example 1. Diagram below shows speed times graph of a particle in 30 seconds. Before do any calculations, refer to the graph, y-axis and x-axis. Make sure the unit used are coherent. In this graph, speed in meter per second times in second, so are coherent. A. Rate of change of speed in the first 5 seconds. So rate of change means find the acceleration. Rate of change of speed equal 30 minus 0 divided by 5. So because first 5 seconds, so equals 6 meter per second per second. B. State the length of times in seconds that particle move with uniform speed. So refer to the part PQ. Length of times equal 20 minus 5. So equal 15 seconds. C. Rate of change of speed of the particle in the last 10 seconds. Last 10 seconds, refer to the part Q, R. Rate of change of speed equals 0 minus 30 over 10, means find gradient, equal negative 3 meter per second per second. So decelerations equal 3 meter per second per second. Negative sign is not needed as the terms decelerations imply a negative acceleration. D. Total distance traveled. So total distance traveled for distance speed times graph equal area under the graph. So find the area under the graph. 1 over 2 times 30 plus 15 times 30. This is a formula of trapezium. So equal 675 meter. E. Average speed. Average speed equal total distance traveled divided by total times taken. So equal total distance traveled 675 divided by total times 30 seconds. So the answer is 22.5 meter per second. Next, example 2, diagram below show speed times graph of a particle for a period of 19 seconds. So in this graph, speed meter per second times second. So the unit are the same. Calculate. A, state the length of time in second. That particle move with uniform speed. So uniform speed 15 minus 8 equal 7 seconds. B, calculate the rate of change of speed in the meter per second in the last 4 seconds. Last 4 seconds, rate of change of speed equals 0 minus 20 divided by 19 minus 15. So equal negative 5 meter per second per second. So you can leave your answer in negative. Also can. Calculate the value of P if the total distance traveled for the period of 19 seconds is 312 meters. So for this type of graph, just find the area under the graph equal 312 meters. Total distance traveled equal area under the graph. So first part, find the trapezium. First trapezium, 1 over 2 times 2 parallel lines, add it together, P plus 20 times 8, the height of trapezium, plus 1 over 2 times 19 minus 8 plus 15 minus 8. This is the sum of 2 parallel lines times the height of the trapezium, 20, equal 312. So simplify, P plus 20 times 4 plus 11 plus 7 times 10 equal 312. Okay, simplify. So you will get P plus 20 times 4 equal 132. So P plus 20 equal 33. So the final answer is P equal 13 meter per second. Example 3. Diagram below show a movement of an object. So refer to the graph. Speed meter per second times in hour. So make sure the unit used are coherent before doing any calculation. A. The accelerations of the object in the first 2 hours. Accelerations, so means equal gradient of the graph. So 320 minus 0 meter per second divided by 2 hours. So equal 320 meter per second divided by 2 times 60 times 60, change to seconds. So from hour is a bigger unit, change to second, smaller unit, so multiply. Equal 2 over 45 meter per second per second. B. The decelerations of the object in the last 3 hours. Decelerations equal 320 meter per second per over 3 hours. So I no need to put the negative because I use decelerations words. So equal 320 meter per second divided by 3 times 60 times 60 second, change to second. So equal 4 over 135 meter per second per second. C. The total distance traveled. So total distance traveled equal area under the graph. So for this graph, the shape is triangle. So use the formula of triangle to find equal 1 over 2 times 320, the height of the triangle, times 5 times 60 times 60. So for this part, you change to the second. So equal 288,000 meter. So equal 2.88 times 10 power 6 meter. Okay, that's all for this chapter. If you feel this video is helpful, please like, comment, and share to your friends. And don't forget to click subscribe. Thank you. See you in next video.